Good day. Today, we want to talk about another concept under calculus, which is known as continuity of functions. What do we mean by continuity of functions? We mean what happens to a function when we find out the limit. Most frequently, we'll see that when we find the limit of a function f of x, when x tends to a, this is frequently giving us f of a. Okay, so this attribute or property is referred to as a property of continuity, and this information is telling us three things. So it says, let's give a formal definition. It says a function f of x is continuous if it's continuous at the point x equal a if one, f of a is defined that is the point a, this point a is in the domain, the point a is in the domain of f of x. Okay, so secondly, the limit of the function f of x as x tends to a exists. And thirdly, this is the limit L is the same thing as f of a. Okay, so these three properties is what constitutes what we refer to as continuous function. So if any of these conditions is not satisfied, we see that f of s is not continuous at x equal to e, or simply say the function f of s is discontinuous at x equal to e. So here is another definition of continuous function. Again, we say a function f of x is continuous in an interval. Let's see, the interval is I. So a function f of s is continuous in an interval I if it is continuous at every point of the interval. If it's continuous at every point of the interval I. Okay. What we are saying here is that for all a in an interval I, for all a we pick in an interval I, we have that the limit of f of x as s tends to a is equal to f of a. So this is what the definition here is saying. So this definition is similar to what we have above. So examples of continuous functions are numerous. So we'll state them one after the other. Okay. So let's say example one. All polynomial functions, e.g., constant, linear, quadratic, cubic, etc., are continuous function. Everywhere in R. Okay, so R, which means a real line. Okay, so all polynomial functions are continuous everywhere. Okay, so depending on the choice of the power. So two, the functions sin x, cos x, and the exponential x are continuous everywhere in R. So let's pick one of these to explain what is happening. What we are seeing here is that for all A in R, okay, we can have the limit of sin x will be equal to sin A. Okay, where this will be finite throughout. Okay, so where this sin A will be finite throughout. Okay, so this also holds for the function cos x, and it's also holds for the function exponential x. So example 3, the function tan x is continuous everywhere except at the point plus or negative pi over 2 plus or negative 3 pi over 2 plus or negative 5 pi over 2. So in that order. Okay, so what we mean is this. So when we plot the graph of this function, let's say for example, let's pick positive or negative pi over 2. The graph of this function behaves this way. So at pi over 2, there will be a jump. This function will jump at this point, meaning at this point there is a breaking, which means that this function is not continuous at this point. So similarly, for when s is negative pi over 2, so we have a similar case of a jump. Okay, that is a similar case of a jump. So this also means that the function tan s is not continuous at this point. Okay, but instead, this point we jump to a point here and continue. Okay, so this is how the tan s also from the right side there, the point here jump to this place, okay, and continues. Okay, so this is how the function of tannets behave. Okay, so we'll classify this order when we get to examples of this continuous function. Example 4, the function ln x is continuous everywhere except at s less or equal to 0. That is, when x is negative, okay, that is if you have x lies in the interval if x lies in this interval, okay, then the function ln x is not continuous there. Okay, this is evidence. If you pick, just say let x equal to 0. Okay, here we have ln of 0 to be, that is, if you have the limit as x tends to 0, okay, so this becomes ln 0, and ln 0 means a vertical asymptote, okay, to the negative part. It means a vertical asymptote, negative infinity. Okay, so this function is not continuous as 0. Okay, so any point other than this, the function is continuous. Okay, so or we simply say that ln x is continuous at the point s greater than 0. Okay, so it means if you pick any choice of x greater than 0, the function ln x will be continuous there. Here are just few examples of continuous function. In our next video, we'll give more examples